Lowell was not alone. Some scientists were shocked when the probe Viking 1 beamed back this image. Is that a human face, perhaps produced by Martians in their own likeness? Until recently, we've never really known where to look in our solar system for extraterrestrial life. But we've always known what the aliens would be like once we found them.
Consciousness. I was on a table.
Usually, there is more than a hint of the Earthling in our aliens. Hostile or lovable, they tend to resemble mutant images of ourselves. As a senior astronomer at the Search for Extraterrestrial Intelligence Institute in California, Seth Shostak has spent his career listening for the radio waves of a distant alien society.
There's no reason to assume that they're going to look like us or even think like us or behave like us or have language. You know, you just have to look at the variety of life on Earth and you see that, you know, nature can come up with lots of different forms.
But if there is life on Mars, how could it survive in such extreme conditions? Since the 1960s, scientists have sent dozens of probes to the Red Planet. The first pictures of the barren landscape quickly dashed any hope of finding intelligent beings. But what scientists did see startled them. Though there's no evidence of Martian-made canals, there are signs that Mars actually may have had water. Some think the angry red planet might once have been blue.
You just have to look back a couple of billion years, 3.5 billion, 4 billion years ago. Mars had a thicker atmosphere, had water on its surface clearly. Maybe it developed life. And as it slowly went bad, you know, the life had to adapt.
Life may have adapted, not died off, because some liquid water may still exist underground. But with no surface water, frigid temperatures, and ultra-thin atmosphere, Mars is a planet only one kind of creature could love: an extremophile. Extremophiles thrive in the cruelest of places. To see where they might lurk on Mars, we head to the Valles Marineris, a massive rift in Mars's surface, 20 times wider than the Grand Canyon in places, and almost as deep as Mount Everest is tall. Lakes may have once flooded this valley, and those lakes could have hosted life. As the water dried up, life could have evolved to cope with the harsher environment. We won't know what these extremophiles are like until we find them. But they may resemble creatures that exist in extreme places right here on Earth. An unusual team of biologists, called astrobiologists, study Earth for the kinds of life we may find in outer space. Astrobiologist Rocco Mancinelli is on the hunt for Mars's extremophiles.
If it went beneath the surface, and some of it undoubtedly did, then what happened to it? Well, it formed brine pockets. So what kind of organism can live in a salty brine? A salt-loving organism.
Astrobiologist Chris McKay thinks he knows the kind of salt-loving creatures that might survive on Mars. Creatures much like those he's found in one of the driest, saltiest places on Earth.
The fundamental challenge to life on Mars is, in a sense, the fundamental challenge of life here in Death Valley. It's dryness. That is the hardest thing for life to adapt to.
Thousands of years ago, a salty lake covered Death Valley, just as lakes filled Mars's Mariner Trench.
Move in closer. This is still wet, a little wet.
This appears like a lifeless place, a big, flat, white, empty horizon. But yet, just below the surface, we find layers of algae and bacteria growing. They're living in an environment that in many ways is fundamentally different from the environment that we sense on the surface. Here you're in a place which looks lifeless, looks dead, and yet you dig down and hidden underneath, there it is.
Beneath the salt is a layer of hardy green algae that survive on the water and light that trickle through. The algae in turn feeds salt-loving microorganisms.
Here in deserts on Earth, dried, salty lake beds, we're going to find them on Mars as well.
Salty deserts are not the only places life might be hiding on the red planet. There are Mars's tremendous volcanoes, some of them 6 times larger than those on Earth. Astrobiologist Penny Boston studies the caves, called lava tubes, left over after volcanic lava has dissipated. Not long ago, we assumed caves like these were devoid of life. They get no sunlight, and no sunlight means no photosynthesis. But in lava tubes outside Albuquerque, New Mexico, Boston has found evidence of extreme life.
Because we know Mars has many, many lava tubes. And so here we have the opportunity to see how these formed and also to look at the life that inhabits them.
The extremophiles Boston has found appear to be thriving. They get their energy by feeding on the minerals in the cave wall.
So here we're up close to the wall, and you can see these white patches here growing against the black basalt. And each one of these is like a major city for these little guys. And they're all nestled in these little pockets in the basalt. And so these guys are permanently adapted to these freezing temperatures. They never see any light, and they get what they can find in the environment.
Are there creatures like these in the caves below Mars's volcano fields? Boston thinks so.
We are going to find life, and I just hope that I live a long and healthy life so that I can still be around to see that.
We may already have had our first glimpse of Martians, not from our visit to their planet, but from their visit to ours. 16 million years ago, an asteroid slammed into Mars and propelled a 2-kilogram rock into space. Amazingly, that rock sailed to Earth and came to rest in Antarctica. Inside, NASA scientist David McKay and Everett Gibson were amazed to spot the outlines of fossils. Water has carved small tunnels in the rock. And in these tunnels, McKay and Gibson found what they believed to be evidence of bacterial life.
These are little microbes, and they're dead, and they're fossils, or in some cases, we don't even see the forms. We see the footprints or the evidence that they were there.
Life from Mars? Maybe. The hunt is only just beginning. NASA plans to send a rover called Phoenix to Mars. It will study the planet's ice cap and probe 3 feet beneath the surface. NASA even has a plan to send human visitors. They may not meet the little green men of our imaginations, but they could encounter life in some form. What will it look like? It is likely to be a subterranean dweller with an ability to survive on little water. Perhaps an organism with a taste for minerals, like the creatures in the lava tubes of New Mexico. Even the smallest find would have enormous implications. Proof that life is not unique to Earth, but exists just next door. Our safari to the places in our solar system likely to harbor alien life now takes us past the asteroid belt on the far side of Mars. Here, Jupiter reigns. But this planet the largest in our solar system, is fairly hostile to life, thanks to its toxic gases and overpowering gravity.
Not only is it pretty cold out at Jupiter, it's also, it's got this really thick atmosphere, tens of thousands of miles thick, and it's got ammonia and methane and, things used to clean the bathroom. But Jupiter has more than 60 moons that we know about.
At first glance, those moons would seem unlikely places to seek alien life. Their atmospheres are thin, and they are inhumanly cold. The temperature on Callisto is lower than -200 degrees Celsius. The scientific probes Voyager and Galileo have detected little on the surface of these moons but ice, with one dramatic exception. Io is one of the closest moons to Jupiter. When NASA sent Voyager 1 to Io in 1979, astronomers were astonished to find its surface roiling with giant volcanoes.
Io is the most volcanically active place in the solar system, just spewing volcanic material from its surface all the time.
What could be heating the interior of this frigid moon? Amazingly, it's the force of gravity from Jupiter. The giant planet exerts enormous gravitational pull on its moons. The closer the moon, the stronger the force. So strong, it can actually stretch their crusts. But some of these moons have elliptical orbits, so as they near Jupiter, the crust stretches towards it. When they move further away, the crust relaxes back towards spherical. This constant tidal movement creates friction deep inside, and that friction generates heat. It's like rubbing two sticks together to start a fire. The pull of Jupiter is heating Io from the inside out. Volcanic fumes and lack of water make Io inhospitable to life. But Jupiter's other large moons are more distant, close enough for Jupiter's gravity to warm them from within, but distant enough to remain calm on the surface. 3 of them look particularly promising as possible homes for alien life. The one furthest from the giant planet, Callisto. On its surface, Callisto looks like our moon, scarred and cratered by countless hits from asteroids. Those impacts may have melted the surface ice for brief periods, allowing life to take hold. But in 1998, the Galileo spacecraft detected a much more promising incubator deep beneath Callisto's surface. Radioactive rocks and tremendous pressure in its core generate heat inside Callisto. The heat may be melting its icy crust from below, creating a hidden ocean. And hidden oceans could mean hidden life. As we fly closer to Jupiter, we find its largest moon, Ganymede. Ganymede is also deeply scarred. Ridges rise above its surface. Those bright spots are craters as big as 5 kilometers across, and likely to be lined with frost. But these photos offer the most compelling clues to where life here might hide. They show flowing glaciers, glaciers that resemble those on Earth. Ganymede's moving glaciers could also be signs of heat within. So, like Callisto, Ganymede could also have a hidden ocean, buried beneath as much as 190 kilometers of ice. The third moon on this leg of our alien safari is the most intriguing. It is called Europa, and of the 3, it resides closest to Jupiter. That